All right, let's ls into the assembly directory. So what we are going to do next is to annotate the sequences that can be found in this file. So this file here has contigs. So we are going to annotate the sequences using Prokka. So we will say Prokka, and then we will specify some options. So the options, we will include those stated in the Galaxy tutorial. So let's just check them. So there's the section for annotation. So we are using Prokka. So we have to specify the input file, which is the fly assembly output. We have that. We also need to indicate genus, Staphylococcus, species, Aureus, and then kingdom bacteria. So we will add these, and then we will include other options as well. So let's get back to the terminal. All right, so I have typed Prokka, and I'll say dash dash genus, that'll be Staphylococcus, and then species, that'll be Aureus, and then kingdom, that'll be bacteria. And then I'll indicate CPUs. I'll say 4. With the CPUs, you can increase it if you have more capacity. Now let's add prefix. So I'll say dash prefix space. And then I'll indicate the sample name. And I'll say underscore Prokka. So what will happen is that Prokka will create a directory that has this name. And in this directory, you will have your output file. So the output files will also have the same name here, in addition to their respective file extensions. All right. Now let's indicate the input file. So that will be assembly / assembly.first_a. So now let's execute this command. All right, so Prokka has started this way. So let's wait for everything to get done for us. All right, Prokka has completed its work, so we can proceed. So let's take a look at the output files. So let's do an ls, and we are going to find this directory. This has the output files. So we'll ls into it. We are going to find our files here. So that's how we do it. Now let's proceed. So I will focus on a few of the files. I will start with this one here. So this file, you can use it to take a peek into your data to look at the features. Example, predicted genes or CDS and all that stuff. So let's display the contents here. We will use the head command. So I'll say head, and then I will indicate the file, which is a TSV file, by the way. So TSV. So because it's a TSV file, the entries here, the data is tab separated. That means it contains tab separated values. So you can open this file here using a spreadsheet software. So take notes. But now I'm using bash commands to get the contents. All right, so I'll do a head to display some of the contents. So we have locus tab, F type, length, gen, etc. So these are the features. So features, CDS, gen, RNA, etc. So those ones are here. So they are tab separated values. So this is column 1, this is column 2, column 3, up to the end here. All right. So for me, what I'm interested in is to get a summary. How many CDS do we have? How many tRNA do we have? How many gens do we have? So I'll do this. I'll just get the features here. Let's just do this again. I'll do the ls again. So I'll get the features. That's what I want. So I'll use the cat command to do that. So I will say cat-f2 because I want the second column, which is the F type. And then I'll specify the file, which is the TSV file. And then I'll do a head to get a few lines So I have them here. So this is what I have. But with what I have, this F type here is not part, there's a header. So I can still remove the header before getting this one. So I can do it this way. So with the same command here, I can say tail -n +2. So +2 means that you have to start from the second line. That's what it means. And I can now do a head. So this will remove that header for me. Okay, now let's expand it. So we have them, but I would like to count how many each has. How many each of them occurs, or how many features are assigned to or belong to CDS or RNA or etc. We are going to do that. So let's do this. So let's do this. I'll reissue the same command here, but this time when I come here, I'll say sort and I'll say unique. So let's execute this command. So this will give me just the features. That's what I want for now. So CDS, RNA, tmRNA, tRNA. So here we see that there are no genes. No genes have been predicted. And so that's what we have. Of course, the data we are dealing with is probably a downsampled one. And so I wouldn't be surprised if we have these things happening. Of course, we can go further into it. All right. So this is what we have for the features. Okay. So yeah, for the data we have here, there are no genes. I would have expected to see genes also here. We have CDS, we should have genes, but that's what we have anyway. Maybe the data is downsampled, or I'm not really sure, but that's what I have, by the way. So I'll just go with it. So it's a practice data, but if you are dealing with whole genome sequence for bacteria, organisms, or bacterial isolates, then you should expect that Prokka also gives you features that are genes. So take note of that. All right, so we can count them. So using the same command here, I'll just add -c, and that'll give me the counts. So I'll execute this command, I'll get a count. So here it tells me 5114 CDS. That means that 5,114 of the features are CDS. We also have 16 RNAs, there's 61 tRNA. So that's what we have here. So this is a simple command to get you started with exploring the data.